This portion of Dream Car Garage is brought to you by XV Motorsports, engineering modern supercars from classic muscle cars.
With regard to the driveline, we're planning on using 5- and 6-speed manual transmissions, as well as a computer-controlled automatic overdrive transmission. One of the parts of the old cars that was a bit frustrating is being on the highway, not having an overdrive gear. I find if I'm driving 4-speed, I'm looking for the 5th gear, and it's just not there.
You know, we can make all the power we want with these 5.7 and 6.1 Hemis in these classic Mopar muscle cars, but if we can't get that power to the ground without breaking parts, it's not any good at all. The only transmission that we could find that would put up with up to 800-900 horsepower is a Viper Spec T56. One problem is that there was no bell housing to adapt it to the late model Hemis, so we cast our own. Now we can bolt it up. Additionally, this particular box has been modified with the triple cone synchros used in the Cadillac CTSV sports car program, so you can shift this transmission at wide open throttle at 7,500 RPM. And finally, we adapted the pistol grip shifter to fit to it, because you know, you've got to make it look right in the car. Additionally, the rear axle assembly needs to be uprated to handle the increase in power as well. We're using the 8 3/4 rear end, updated with modern components to handle the power. That includes alloy axles, high strength, a 489 gear case, which is made in the aftermarket now and has improvements on it, billet side adjusters, all those things that are going to give it strength and durability. And then we fill that with a choice of gear ratios from 373 through into 411 range. We use 2 different types of limited slip differentials, either an improved sure grip type, which is clutch plate technology limited slip, available in either a street version or a higher torque bias street strip version, or an all gear drive differential, which is ideal for open track. We take the 8 3/4 housings, we check them for straightness, sandblast them and powder coat them, assemble all these components into them, and we're good to go. The final component in the driveline upgrade is an aluminum drive shaft. This ties the transmission and rear axle assembly together. It reduces the NVH because of the lighter weight, and it'll handle the increased power output. There is no existing fuel system upgrade for putting high-powered, late-model EFI Hemi engines in these vintage muscle Mopars. So, this is a 71 CUDA fuel tank. This is the bottom half of a reproduction fuel tank. We're going to install a sump, which is going to provide a reservoir for these twin pumps, high-powered. They will provide enough fuel for up to 1,000 horsepower, and this reproduction sending unit and pickup tube assembly will go up through the stock top. We'll end up with a fuel tank that appears stock from the outside and yet can support much higher power levels. This product will be used both to build the extreme velocity muscle cars and available for those doing it at home. We also integrated an OEM inertia switch into the fuel pump wiring. This safety device will shut off the electric fuel pumps in the event of a collision or rollover. To move the fuel from the tank to the engine, we had to make stainless fuel lines, 3/8 ID, plus or 5/16 return line for the EFI system, and dual 3/8 lines for engines up to 1,000 horsepower. Another system requiring upgrading for the increased power output of the new Hemi engines is the cooling system. 3-inch aluminum radiators were developed for use both on the E and B body Mopars. These radiators have greater thermal capacity with the larger size, and correct sized inlet and outlets for the 5.7 and 6.1 Hemi engines. An aluminum fan shroud and electric fan complete the cooling system upgrade. Next week, we take the CUDA to the track for testing.